Okay, good afternoon, everyone, and good afternoon to Dr. Pruk Aggarangsi from Chiang Mai, Thailand. I would like to thank you for joining and accepting our invitation as one of our speaker. This research talk is actually a program organized by our institute, Immb, for researchers to share about their topic of interest. This talk serves as a tool to gain knowledge and insights on a wider research area and enhance basic understanding in scientific methodologies across different disciplines. It provides an excellent opportunity and platform to establish social network among students, researchers, and also speakers. So I would like to invite our former IMMB director, our entomologist, Associate Professor Dr. Hyo Chong Chin, to further introduce our speaker for today.
All right. Thank you very much, Aisha, and good afternoon to all of you. And first of all, I would like to thank Dr. Pruk Aggarangsi for accepting our invitation. And also, I'd like to congratulate Associate Prof. Dr. Wang Seok Mui, who is the new director of IMB. So welcome, everyone. Yeah, thank you for coming to our IMB International webinar. And without further ado, I would like to introduce a little bit about Dr. Pruk Aggarangsi. Dr. Aggarangsi is an assistant professor in mechanical engineering at Chiang Mai University in Thailand. He is also the director of the Energy Research and Development Institute, NACOPIN, ERDI, at the same university. He holds a PhD and master degree in mechanical engineering from Carnegie Mellon University in the US. And he also obtained his bachelor degree in mechanical engineering from Chulalongkorn University in Thailand. His research primarily focuses on renewable energy with a particular emphasis on biogas system, biomass power plant design, and waste to energy project. He has contributed significantly to the development of biogas technology in Thailand, especially in the agricultural and industrial sectors. Dr. Aggarangsi work includes numerous publications and projects related to biogas production, biogas system efficiency, and the application of biomethane as a green fuel alternative. And so with that, it's very impressive biodata. So let's hear from Dr. Pruk Aggarangsi. Thank you so much.
Thank you. Thank you. Very kind introductions. And welcome the executives and audiences to this about 1 hour webinar that we can discuss across many topics. But today, as being kindly introduced into biogas system. So today's topic is more or less into the biogas as a tool for sustainability and how does that technology can play a part of so-called carbon neutrality pathway of Chiang Mai University. So let's move on to Thailand long-term greenhouse gas emission strategy. And everyone knows that every country has signed so-called COP or COP agreement on an international stage that more or less at one point in time, each country has to meet either carbon neutrality or net zero in more or most activities of the countries. Then the long-term goal in case of Thailand, if we look at the carbon neutrality goal, the neutrality goal is 2050, which is about 25 years from now. And Thailand has promised to be net zero greenhouse gas emission by 2065. And this is so much of a hope, big hope into future development of future technology, because to be honest, I don't think anyone knows what technology is going to be available in 2065. And we all hope that technology will help us more or less emit zero emissions. But for the time being, what we can do is along the way to 2055, whatever you're producing, you are taking it back or offset it with other carbon negative activity. So that's the idea of this strategy. So along the way, the Thai government, which includes us as Chiang Mai University, is public university, so we are following closely with the government policy. So along the way, plan and policy has been announced. A few things that needs to be focused is 2035, Thailand is aiming to have at least 69% share of electric vehicle, but that's only for the new vehicle, meaning the sales has to be at least 69-70% electric vehicle within the next 11 years or so. In the next 12 years, the achievements of CO2 removals of 120 million tons of carbon dioxide has to be achieved through forestation, more plantations in terms of carbon sink. And along the way, there are many targets, especially in terms of energy, renewable energy, and waste management. So that's where we are. So Chiang Mai University itself has a very big carbon footprint. We have been tracking our own footprint since 2020. And last year footprint is very, I would say, not surprising, but scary. Basically, Chiang Mai University, we have around 30,000 people plus a hospital. All that together, we are emitting about 58,000 tons of carbon dioxide emissions. So apart from that, if we had not done anything, the emission would be around 80,000 tons. So from 2020, Chiang Mai University has implemented so-called carbon neutral pathway initiatives into the campus, of which we are going to talk about. So all those initiatives, they are separated into 5 themes, as you can see on the right-hand side. It's basically, the first theme is organization management, meaning all of the organization or administration for Chiang Mai University has to at least know your carbon activities, meaning at the end of the year you're enforced to report carbon activity, such that is why we can have this number. And along with that, mitigation measure has been introduced also from the policy level, from the university level, and from the organization level, meaning faculty level, schools levels, and campuses level as well. So all of these measures are all of these measuring policy are issued from the policy level and then implement into the organization level. And that's why we have these numbers and so-called the reduction numbers. A part of this mitigation, together Chiang Mai University, we are quite lucky that we are located in the northern Thailand area, and we have quite some land available compared to Bangkok. University in Bangkok or in big city like Kuala Lumpur, I don't think you can easily plant more trees. But Chiang Mai University, we still have some space available. So the so-called carbon offset and sink project, especially planting more trees, is also available. And it does contribute to these footprint reductions. And altogether, it's not just making your campus great and making your campus footprint small. You really have to share the knowledge. And I think this webinar is a good example of this theme, that we are more than happy to share what we are doing and this knowledge. Apart from the publication that is mission for every faculty members, this kind of sharing opportunity is also very welcome. We are happy to participate. And then the last thing that we cannot forget is adaptation and resilience. Chiang Mai itself has suffered from many natural disasters and it's been growing more and more extreme throughout the year. So apart from this carbon reduction, we also have researchers and teams working on adaptation. For example, we have a huge problem of pollution, dust pollution, so-called PM 2.5 pollution. So we help people to adapt and protect themselves and resolve those kind of problems too. So this theme has been implemented since 2020, and altogether we can discuss more or less what we have done, what we have achieved, what we have failed, and so we can learn together. So when we talk about carbon neutrality roadmap, it's a graph like this. So obviously we implemented in 2019, 2020 as I mentioned. The good number, if you still remember, the target of Thailand to be carbon neutrality is 2050. It's 25 years from now. But somehow our president and our executive team decided that, okay, Chiang Mai University has to be quicker. And that's a lot quicker. It's 18 years quicker than national goals. So the announcement of CMU itself is by 2032, which is about 7 years from now, we're gonna have to be carbon neutral, and that's very challenging for us as a researcher and for us as executive of the university, meaning a lot of resources and implementation has to be switched on and implement such that we can follow our own public policy on carbon neutrality. So on the right, you can see the map of Chiang Mai University compared with the Chiang Mai International Airport right here. You can see the runway. And the campus of Chiang Mai University is, there you can see 3 areas. Number 1, the light gray area here is the main campuses where you have most of the faculties and schools and most of the lecturing going on in this campus. And second is the light blue campus. We called it the agriculture campus. And this is where I mentioned before that we have available space to do more plantation as carbon sink for the university. And the dark blue campuses is medical campus. It consists of 2 hospitals and a lot of medical offices. So if I can give you some balancing idea, the lecturing campus consume a whole lot of energy because a lot of people live and learn and eat and stay inside this campus. So a lot of waste are generated from this campus 1, the main campus. Along with the medical campus, you consume a huge amount of energy because all of the hospital, I think it's 2,000 bed hospital size. That's the biggest hospital in the northern part of Thailand. So the energy consumption is so huge. So the footprint is very heavy. Carbon emission is very heavy for these campuses. On the other hand, the agriculture campus is basically carbon negative by itself because there's a carbon sink and you have available space for either install more solar energy or you can install, which I will show you in a few moments, the waste to energy project that can produce some energy. So this is basically the carbon negative campus trying to balance or offset the 2 main campuses. So this map is basically for the agriculture campus, or I just mentioned the carbon negative campus. It's also called a biopolis campus. This campus is dedicated. Our office as Energy Research Institute are also located in this campus here on the far right of the map, right here, the Energy Research Institute. So we are here to demonstrate that this kind of land can really be carbon neutral or even carbon negative to carry on and offset the burden of other campuses. So in this biopolis model, we have lots of plantations, food plantation, research plantation, and also forestry plantation just for carbon offsetting. We also have so-called waste management center on the very north of the campus. All of the waste generated from all three campuses will be delivered here to manage such that we never allow methane emission to leak out to the atmosphere. So that's one way to capture or to reduce our carbon footprint. Okay, you can probably it's funny for you, but in Thailand it's for real that you're allowed to plant cannabis. Okay, it's probably illegal in Malaysia and in Singapore right now, and also in Indonesia. But in Thailand, it's legalized, but you only are allowed to do it in a controlled environment and control area. It's not free to consume. So a cannabis plantation is also located, and mainly the cannabis products are for medical usage, medical productions. Okay, and other than that, there are food production, food innovation and packaging, and many things that has biological research concern. Okay, so apart from this campus, the main campus and every campus are implemented with so-called smart energy theme or smart energy implementations. The main idea is number one, to have a cross-platform data collections. So meaning in order to do anything with the electricity consumption or productions or clean energy, you have to know the basic data. Meaning every building, by the way, CMU has about 400 buildings on campus. So every building has to be monitored through these devices. And once you know who is consuming what, at what time, what are their behavior, then you can start doing demand management, meaning increase energy efficiency. For example, you can replace old air conditioners with newer version, higher efficiency. You can replace old versions of light bulb to LED lights. And once you've done that, you have managed pretty much the demand side to be quite efficient. Then we can start talking about producing renewable energy. In Chiang Mai University, we have installed about 12.5 megawatts of solar PVs on 250 buildings. And all of these are being consumed on site, and only on holidays that you really produce more than the demand. So basically, and right now I think you all know that installing solar panels is very feasible financially by itself. So we have zero questions of implementing this. If you have rooftop available and they are strong enough, there's no question that you should or should not install solar panels. You should definitely 100% solar panels. By the way, because we have three campuses, as I mentioned, the loads are on these campuses, and the productions also are on these campuses, but also from the agriculture campuses. So many times that in agriculture campuses, you cannot consume all of the energy produced. So this is why we also install energy storage, ESS, is battery energy storage. The capacity is about 1.2 megawatt hour. Why do we have to do that? It costs about 500,000 or 600,000 US dollars. We have to do that because since we want to be carbon neutral campuses, meaning you cannot just consume solar panels whenever it is produced, because solar can never produce anything during the night time. And that means if you have this energy storage, you can drive this campus, agriculture campus, to really close to a net zero energy consumption. So that's the idea of having this energy storage. And also, we also install some solar collections to produce hot water for dormitory as an energy storage. So you don't really have to install electric heater for hot water in the dormitory. So that's the idea of energy management. Okay. And also on many buildings now, the energy management and sometimes it's called energy manager is installed or integrate with a transformer. So basically, in the past, the building only see one transformer only to transform high voltage to low voltage that you can use. So in many buildings now, the energy manager are installed and coupled with the transformer such that these brain are selecting either the electricity from the transformer or from the solar panel, or sometimes from the energy storage are selected and feed into the building. So these are the ongoing project that CMU is doing right now. So that's the electricity part. So waste management part, which is the key concern or key topic that I like to share with you today. We used to think that if we pay municipality, for us it's Chiang Mai municipality, and we don't have to care what municipality will do with our garbage. They can carry them or transport the garbage to whenever they want, do whatever they want, and it's not our problem. So Chiang Mai University is thinking differently, meaning we really have to care. And once we go and inspect what Chiang Mai municipality is doing, it's not satisfactory if we want to pursue so-called carbon neutrality. Because I think it's also true in Malaysia and in most of Thailand as well, that garbage in our country, they're not pre-sorted, meaning a lot of food waste are being mixed with other garbage, and that makes everything very difficult. So usually you have these landfills, this is the bottom of the landfills, and the garbage will be covering these piping system, and then when you pile up the garbage, eventually the methane will leak out of this pipe, and then you can either manage the methane later. We thought it's good enough. So obviously it's not quite good enough, because lots and lots of methane are still emitted to the atmosphere. So that's why we initiate the use of biogas, since also it's lucky for CMU that our institute, the ERDI Institute, has a lot of experience in biogas. And biogas is basically the closed system that produce methane, forcefully produce methane out of either livestock waste, and that includes garbage, organic waste, industrial waste, or either sometimes energy crops, and produce methane, and those methane can be used as renewable energy either for electricity or for heating or for cars and trucks. And at the same time, the garbage or wastewater are treated, and then the water can be reused on the activities. And then the point is, if you capture methane, everyone knows that methane consists of CH4, carbon and hydrogens. So on the methane side or carbon side, you never take any nutrient out of the system if you divide it in the middle. On the methane side, if you produce methane and utilize methane, when you burn methane, you get carbon dioxide. Those carbon dioxide being absorbed back by plantation and into the activity. So the carbon cycle has nothing to do with the nutrient cycle when you are working with biogas. On the other hand, other ways like protein, nutrients that exist in waste, in organic waste, is being digested in this digester, and nutrient has nothing to do with the right hand side. You can recycle this nutrient as compost, and it also goes back to plantations. So this is why we believe that biogas should be solving the existing problem of garbage management, wastewater management, because the nutrient cycle is very complete as well. So if you compare this with incinerations, when you incinerate garbage, mix garbage, food waste and everything together, generally all the nutrient is being burnt off. If you're lucky, it won't be burned off into NOx and SOx and other toxic gases if you can capture them in time. But sometimes you're not so lucky. These nutrients will be burnt off and produce toxic gas, and it's even worse. So that's why we have a true belief that food waste or organic waste should be properly managed on site before other material like plastic or papers or wood chips to be sent to incinerations. So that's the idea. So since we have initiated this idea from 5 years ago, we draft up the plan to build this so-called garbage management center with the biogas system. If you can see this small graphic, you can see a square or rectangle. Oh no, it's a cubicle digester here. That's the heart of the project. That all of the organic waste, including food waste, some animal waste, some plantation waste, they can be delivered and digested into these digester or reactor. And apart from that, our accessory, for example, if you want to deliver normal garbage, you probably want to have a sorting equipment which is semi-automatic. If you want to do compost, you probably want to have a compost area, and the gas can be used to produce electricity and also a vehicle gas if you want. Okay, so this is the target of the project. Okay, so before having these waste to energy plants, about 3% of the recycling material are being recycled. Why is that? Because many times when you mix food waste with recycling material, people do not want to touch it, even if they know that these are recycling material, recyclable material, and they decided to just leave it in the pile of garbage. So once you have this recycling center, we expect to have more than 5% recycling out of the whole garbage. Okay, methane emissions. If you don't capture methane, the amount of organic waste contaminated in the garbage pile will emit about 500 cubic meter or around 250 kilograms of methane are being emitted every day. So once the system is on site and we can capture most of the methane, we expect only 3% out of this to be a leakage from the system. So that's 97% reduction in methane emissions. So that's the key idea of why we are doing that. Apart from that, we send some of the garbage to incineration. Usually, at this amount of organic, about 50% or so, and about 40% humidity, uh, the calorific value of this garbage is very low, and then roughly you have no value out of this so-called RDF. Once we can separate food waste out of this garbage, we can expect a good boost in calorific value or heating value of RDF because the humidity should be coming down to less than 30%. Right? And also you can prevent some other material from coming in. Okay. Before that, we have no material upcycling. Once you have these selection sorting equipment, you can expect more plastic recycle and more green waste upcycling recycle, right? And more or less, if you don't have the system, 97% of the garbage, apart from this 3% recycle, they're all being landfill. That's not good, right? So once the system, waste to energy system is in place, you should export less than 10%. And those 10% are basically inert, which has no active ingredients to landfills. So that's the idea, right? So the system that implemented consists of three parts. Separations, so fresh garbage here, separation for normal garbage, some organic feeding. If you have separation, if you have delivery of food waste directly, you can skip the separation and feed directly to the feeding system. Feeding system comes down to into the reactor or digester to produce methane. Methane then being fed into electricity production and vehicle gas production. The effluent is being post-treated in further biogas treatment and then released to post-treatment ponds. So the system looks like that. Okay, sorting it's basically man sorting together with some shaking machines, and then the rest organic part goes to organic shredder and to the digester. Okay. So digesters, the size of the digester is 600 cubic meter. The amount of biogas should be maximum at 900 cubic meter per day, but currently we produce at about 500 cubic meter per day. So these are the real picture of the completed size. This picture is being captured in 2018 when it was newly built. Okay. So this is the machine. You can see it's still very new. If you visit it now, everything is old. I wouldn't call it dirty because you are dealing with garbage. You try your best to clean it up, but it's going to be look dirty. So these are sorting machines. So the first step of the sorting machine is human picking recycling material. This is where you can recover more and more recycled material out of the garbage stream. Okay, these are picking station, and from picking station, the garbage will be delivered to shaking, so-called sorting machine, where the aim of this machine is to shake out the heavy and wet material on the very bottom here, to be fed into organic waste, organic reactor. And when you shake the organic part out, hopefully the plastic and other material which cannot go down to the organic part will be separated and be recycled more or being packed as fuels to be sent to power plant or incinerations. Okay. Then the organic part is being fed into this digester, which is located in the next building, next to the sorting building. And then inside, of course, is anaerobic digestion, meaning no oxygen leaking in or out. And altogether, with the work of biological process, you produce methane or biogas collected into this balloon, round balloon. Everything is basically electronic control, including the gas production and gas utilization. A part of the gas is being upgraded and used as vehicle fuel. So you probably have seen this, especially in Malaysia, where you have, I believe, some taxi is being run on natural gas. So this system is basically the same system, the system that's produced the same gas as natural gas that you dig up out of the underground or under the sea. So once you can produce clean natural gas, which has about 91% methane, compared with 60% methane from the raw gas. Once you have that gas, you can compress that and feed into a vehicle. So in CMU, we have this kind of, we call it purple bus or purple van. This van is run on your food waste and possibly some other organic waste. And these are fed with this natural gas directly to these natural gas vehicles. And this one is in service to students for free. Well, we can say free because it's already included in the tuition fee, but it's free. So the students, the promotion or advertisement or the feeling that we want to convey, the message that we want to convey to the student is that, okay, you ride this bus for free between campuses. Every kilometer that you travel, you actually reduce carbon dioxide emission, or your travel at the negative carbon transportation mode. So that's the idea that we convey to our students in terms of this program. So altogether, this program, the electricity is about 1 kilowatts. We intake about 30 tons of waste, including food waste, per day. That's the maximum. Generally, the intake runs about 15 to 20 tons per day. And then the gas is fed into this 100 kilowatt biogas digester, and about 30 kilogram per hour of the vehicle gas production. So altogether, this is how much carbon dioxide reduction that we claim that we have reduced, that we have shrink our carbon footprint. If you still remember the number on the first page, we shrink from 80,000 down to 58,000 by investing into this program. That is about 10,000 tons per year of contribution. Okay. Apart from that, we have help. This is not CMU campus. This is a palm oil mill wastewater treatment plant in southern Thailand. If you remember, we are located in the very north of Thailand. We have this opportunity to help out with this palm oil mill in southern Thailand to produce the vehicle gas and deliver this gas to the gas station itself, just to prove that this gas is being used as commercial gas. You can actually sell this to a vehicle at the gas station with a stamp from the Ministry of Energy. So we have this kind of so-called demonstration/research facility to produce this gas in a very, very commercial scale. It's about 4 tons per day. And this plant is actually making money every day. Right? And on the other hand, we also help, sorry, it's in Thai, we also help small scale livestock farms owners that they don't really have to invest into big digester, big wastewater treatment to be complied by the law, to be complied by regulation. So we invent this so-called biogas bags. It's a one-day installation. You only dig up 10 by 2 space and just put down this gas bag, pipe in, pipe out, and then it's ready to use. So that's some product that we invented for the small farms. Okay, and these are the big farms that it just referenced that the biogas itself is a very big idea. Maybe people already forget that in order to produce food, you actually produce wastewater along the way. So we help this food industry to produce biogas. This is the picture of one of the biggest biogas plant in Thailand. This plant produces about 6 megawatt of electricity, and it's located west of Bangkok. This is also one biogas plant that we help in designing. So this is palm oil mill in southern Thailand. You can see that the shape can be different. The size can be very different from industry to industry. This is also palm oil mills in southern Thailand. And also we help some farm or some palm oil mill in other countries as well. Actually, I think this is near, I don't know, near Kuala Lumpur, I guess. This is a palm oil mills, and we help this company. They are located in KL, so-called Sakti Surya. They work with palm oil mills. They sell equipment, but we help them design this biogas from palm oil. It's since 2019. And also this one is Sabah, Malaysia as well. So we also help designing these plantations to have methane recovery system. This one is also Malaysia, I think. Medan, Indonesia. This plant is in Indonesia. So we help them design this one, Jaho. So, okay, it's good that we have quite a bit of activities in Malaysia that I can share with you. So this is coming through my conclusion now for today. So we have to dare to think that whatever we are doing every day, it could be wrong, right? So the point is, Thailand and also same in Malaysia, we have been practicing this garbage management, meaning landfill, for I think 50, 60 years, 70 years. And we think it's okay because at least our house is clean. When we rethink that, and we think about all of the value chain along the way, you can obviously see that this model is not good enough. You will emit a lot of methane outside, and methane is one of the very, very high potential greenhouse gas. So thinking on the other side is that, okay, methane is actually has values. It's a fuel. It has heating values. And in fact, if you collect 1 ton of food waste, you can easily produce 100 cubic meter of biogas, or about 50 kilogram of methane, right? 50 kilogram of methane easily. So that's why we have to start thinking that, okay, sometimes the practice that we've been doing has to change. some investment has to be in place, some policy has to be in place. The second thing is when you change people, that's a big question if they are going to follow. So that is why we start doing this or practice this in campus, on campus first, because we have a tendency of people to follow us, either following us because they think we are doing good, or following us because of the regulation that we have to practice. So either way, it's much easier to practice on campus than expand to municipality and real cities. So one of the obstacles that we have seen is the food collection. If you want to separate food waste, you have to have separate food waste collection routing or logistics, and that increased cost in management. So if you want to commit that, the executive of the university have to commit the cost into that as well. So when you do that, you separate food waste, then the rest of the material are high quality, meaning they are drier and they don't tend to get rotten and get smelly. So it's very likely that you can send these material to incineration power plant, so you can earn value out of that. So at the end of every project, community engagement and sustainability mindset, that you have to really communicate with people, in our case on campus, and people around the campus to participate is number one success factor. If you cannot get participation, I think it could be the waste of money. But anyway, the point is, I think what we are sharing with you today is it can be possible. It's very possible. The technology is not very high tech. It's not very difficult to control. It's more or less the decision or the mindset of the executive themselves, if they think this is important, and of course the availability of resources in terms of space and budgetary. But if you're committed to this, I think practice like this can be successful. So I think this is a very good time to stop and discuss more. Okay, do you have any questions?
Okay, thank you, Dr. Pruk, for the informative and eye-opening talk. We have some time left for Q&A session. If any of you have any questions, please unmute yourself or type your questions in the chat box. I will try to address the questions one by one. Type your questions in the chat box. Okay, we have one question from Dr. Wang Siok Mui. Many thanks to Dr. Pruk for the very informative presentation. In your experience, what is the most effective way to communicate the concept of carbon neutrality to students? And what practical steps can students take in their daily lives to achieve a net zero campus?
Right. I think that has to be in multiple levels. Generally, I think the executive level has to make clear what the policy is and what the goals are, and then communicate very well with the dean of every school and the staff of every department. And then in the student level, I think it's very good to really get into their routine activity. For example, get into social media that they are checking, put information into social media, put some activities that they can participate. For example, we have a competition in garbage reuse design competition, or competition in sticker design for energy efficiency. So we implement these kind of activities to the students. So basically the answer to that is at the staff level, I think regulation works best. So they have to really follow these regulations. On the student level, it's activities after activities. In Chiang Mai University, we used to have a junior senior activity, freshman welcoming activities. So right now we are not allowed so-called abusive activity. We used to be famous for that, but now it's not allowed. Like you talk toughly to the freshmen to get them tougher. It is not allowed anymore. It is considered abusive. So we try to implement creative activity into these activities instead. For example, okay, all of the freshmen come through garbage sorting facility and you can try to sort the garbage and you can see for yourself if the food waste are mixed with the garbage, it's very difficult to sort. If it's not mixed, you can easily touch them and sort them. So that's the idea of activities that we implement to the students.
Okay, we have another question from Dr. Hyo Chongchin. Great presentation as always, Dr. Pruk. May I know what is the initial cost that the university needs to invest in order to start the biogas facility in Chiang Mai University?
Right. The capex, the investment itself, it costs around $3 million initially. The operation includes about 8 workers with 1 manager, and then 3 or 4 trucks to collect food waste and garbage. So altogether, it's basically $3 million plus some operating costs. But I think, that's worth it. But to be fair, if you don't invest into this facility, you have to pay municipality to manage your garbage, and the rate is about $20 per ton. So that's pro and cons in this as well.
Any more questions? You can unmute yourself. We have one more from Nur Aida Laili Mislan. What opportunities are available for students to contribute to the university's goal of becoming a net zero campus?
Right, very good questions. Actually, I forgot to mention about that. For when you are newcoming or freshman, fresh lady at Chiang Mai University, you'll be trained or educated for sustainable living from day one or from first semester. Basically, in the canteen, you can obviously see that everything must be separated. Like food waste definitely has to be separated. You are encouraged to have your own water cup, such that you use less plastic bottles. You are encouraged to have your carry bag because we practice the non-plastic bag policy on campus. So these, we hope that at least the students spend 4 years with us, you embedded this thinking that this is a sustainable living, and we really hopeful that when students go out and live in the actual society, they can expand this idea. And and of course using public transportation is one of them. So that's our activity that we practice.
Let's wait for 1 more minute, Dr. Pruk, for more questions.
Okay.
from Dr. Hyo Chong-Chin. May I know what are the big challenges having this facility in CMU campus?
Okay. At first, we have quite a bit of obstacle or disagreement, especially between campus staff. People are always afraid that having your own garbage management will have bad negative impact. For example, smell or probably rodents problem. So we really need time to prove that these facilities, if they are well managed, they can be pretty clean and very neat. But yes, you have to put more effort in terms of managing it. So yeah, it's a big challenges. But right now, I think no one is opposing this idea. Everyone is getting used to it. We even built a dormitory next door to the garbage management. Not dormitory, it's staff member apartment. So no one is complaining about anything because there's zero impact if you manage it well. So thank you for the question.
Okay, I think that's the only questions we have for today. So I would like to take this opportunity once again to thank Dr. Pruk Aggarangsi, Assistant Professor in Mechanical Engineering, Chiang Mai University, as well as the Special Representative in Clean Energy, Energy Research and Development Institute Nakhon Ping, Chiang Mai University, for your insightful and engaging presentation. Your talk has given us valuable perspectives to consider. We really appreciate the time and effort you put into sharing your expertise with us today. It's really an honor for having you around. Thank you once again for your contribution, and also I would like to thank everyone, the online participants that joined us for today. Before signing off, please fill in the attendance form. I have shared the link on the chat box. Thank you so much, everyone.
Thank you. Thank you.
Thank you, Dr. Pruk, for your time and very inspiring presentation. I appreciate it. Thank you so much. Thank you.
Very well.
Hope to catch up with you again. All right. Take care. Take care. Bye bye. Yeah.
Dr. Pruk, I think we have missed one question here. The question
one.
just came.
Okay.
Thank you, Doctor, for the informative sharing. If I may ask a simple question, in your experience, which is harder to be convinced to take part for a more sustainable, greener world? Is it the villagers, students, or industry heavyweights?
Right. I would say industrial themselves, they know what they're doing. If being sustainable, being more profitable, usually they're saving money in terms of doing sustainability. So they're not very hard learner. Villagers or normal citizen, on the other hand, who think you are already doing good, doing well in your life, that's the hardest to convince. Students, they are very, very open mind, very eager to learn, and including students everywhere. I think it's a very good opportunity to communicate with students. Yeah. Okay. So thank you for today.
Yeah. Thank you once again.
Bye.
Take care. Bye bye. Yeah.
Bye,
Thank you
Doctor.
all. Thank you, everyone. Yeah.
Thank you, Doctor.